Hello, everyone. It's a pleasure to be here with you today in this new year 2023. We hope you had a great break and relaxing holidays, that you could enjoy some good time. And it's a pleasure to see that you haven't forgotten about the AI Research School and you're still here and still want to keep learning. Today we are going to go a bit deeper into more complex Python after the introduction to Python sessions that you have had before the holidays. So today we have the chance of having a great instructor, which is returning from last year because he is a really good instructor and he loves doing that with us. So thank you very much, Saman, for your time. So Saman Rabar is a senior applied AI scientist. He has extensive industrial and academic experience working with biomedical data, signal processing, medical imaging, natural language processing, speech recognition, and e-commerce data analysis. He's currently working as a senior applied scientist on an enterprise-level automatic speech recognition system, and previously has worked with a team of brain scientists and brain-computer interface. We love Saman because he is giving really nice workshops and students love him as well. So we're really happy to have him today. And today he's going to talk to you about scientific programming in Python. He's going to give another session soon, and overall he's going to present some scientific libraries that you can use in Python. So thank you very much, Saman, and feel free to get started.
Thank you so much, Sebastian, for your nice introduction. I appreciate that. And thank you, Dr. Maliki, for this great opportunity and chance. And glad to see everyone here. I see there are a lot of people here. That's exciting. Let me actually share my screen. Okay, can you guys see my screen?
Yes, we can see your screen. It's a bit zoomed in, but we can see it.
Oh, gotcha. Okay, yeah, that's okay. I actually did it on purpose so I can for people to see. Okay, so hello everyone. My name is Sam, and I think today's session, what I want you to again get more familiar with the fundamentals of data science, specifically NumPy. If you can get into a little bit of pandas and like a little bit of a use case study, because we're going to have two sessions, and we're going to dive deeper into the components that we have here for the first session, which is today. The session's agenda, I want the session to be interactive. So please put your questions in the chat box, and then if you have any questions, please let me know. And if you get bored, let me know too, so I can actually interact with each other more and see what your questions are. So today's agenda, we're going to talk about Python and basic concepts in Python. Introduction to NumPy and Pandas. We're going to have a case study, movie-lens case study. We might not be able to cover the whole thing, but again, the next session, we would basically cover like more details with more additional case studies. An overview of some data sets, how to basically parse different data using NumPy and Pandas, and try to look at it in a scientific way. So what I want you to focus on in this session is also the way this notebook is laid out, from objective to basically the way we go through each library to basically the case study itself. Because again, one really good skill to acquire if you want to get into data science work is knowing what tools you should use, and how to look at the data sets, how to open the data set, what questions you should ask yourself first, and then start doing the process. That's what data science is all about. And I know you have some basically, again, you had some session in Python, like the basics of Python, but I'm going to go quickly over those to refresh your memory. So bear with me. And again, if you have any questions, just let me know. So again, majority of the time for data science stuff, we use Python. You often see other languages too, but they're not pretty common unless you do something very fancy, just like modeling and stuff like that, like C++, Java. But most of the time, majority of the time, you would use Python, specifically with the libraries that we're going to talk about, like pandas and NumPy. So that's why I want to put an emphasis on the core concept of like fundamentals in Python. So again, what is a variable in Python? You are familiar. Variables are just like containers that can hold values, right? A piece of information that you can reuse for a different process. We can think of it as buckets of information, and you look into that bucket and you would see, for example, a cat is jumping out. So that cat is basically one piece of information, or just like one object in that bucket, which would be the value of a variable that we're going to check. So variables are buckets, basically. To store information, variables are names for values. In Python, the equal symbol assigns the value to right to the name of the on the left. You're familiar with all this stuff. You can assign and reassign values to different variables. So again, here we have a variable, age, number 42 is assigned to it. And again, we talk about the data types and stuff like that. I think you're familiar with the data types. So again, who can tell me in the chat, just like to get it going and get it more interactive, what is the data type of this one? Again, are you familiar with data types? If anyone has any information about that, excellent. Okay, so right off the bat, I see lots of people just like mentioning integer. Okay, I know you have a good understanding about this stuff then. So it's really important to understand the data types. As basic as it might sound, the core concept, especially if you want to get into algorithm design and stuff like that, is understanding your variable's type. Because if there's a mismatch in the type, you might basically get strange errors, and then you might get into this vicious loop of not knowing what's going on. So you can simply check the data type. Integer, this is a string, and that's how we basically work with variables in Python. So variable names, we have conventions, you know, what kind of conventions you can use. Basically, variable names can only contain letters, digits, and underscore, cannot start with the digits, don't do it. Are case sensitive. So again, be careful if you have assigned the variable age, and if you basically define another variable age, these two are different, they're case sensitive. So be careful about like these edge cases. So variable names that start with underscore like this have a special meaning. Again, if you're familiar with Java or like a more object-oriented language, you know that they're hidden variables. Like there are variables that they're private variables that not everyone can access. So in Python, in order to signify that to other users, or if, for example, you're doing some stuff that some other, for example, your collaborator is going to use, and you know that this variable shouldn't be changed often, you can just like do this. And that signifies that this is a private variable, and not everyone can have access to it. Again, you get familiar with this when we get into object-oriented Python, just like get familiar with classes and stuff like that. But this is just for your information. And then you can use print to display different values. So for example, this print function, I'm basically printing the value of this container and this. And there are many different ways actually to do that. This is like a conventional way of doing it, like prints basically accept different arguments, prints name, which is the value of this variable, first name, and then is a string, age, the value of this other bucket, and then this one. Or you can do it in another format, which is called fstring, and it's like this. You have like a double quotation, and then you have these curly braces, but then inside these curly braces, you would put the container, the variable, and then basically all the other stuff would be string values. So again, first name and age inside these two curly braces would be your container, your variables. But then you have to use f at the beginning with these, again, quotations. So this is called fstring. I like using this. This is actually newer, and you often see it basically getting used in industry more compared to this one. So again, important notes. I know you're all familiar with this, but just to refresh your memory, variables must be created before they are used. So if specifically if you're using Jupyter notebooks, if you use a variable, for example, if you define a function at the top, and then it's using a variable, but then you define a variable underneath that function, if you go up and execute that cell, that variable wouldn't exist unless you come here and execute the cell below it. So always remember that variables must be created before they are used. So again, maybe a good practice is some of the variables that are global, that are going to be used across the notebook, can be defined at the top. So you execute them once, and then you can reuse them. It might not be good engineering software. The software engineering practice might not be good. Like you have to be, again, I'm not going to get into that, but this is called global variables, and they're used for specific purposes. If you know the same values for those variables are going to be used over and over again, and they're not going to be reassigned. So just some pro tips, and then we're going to get into this. What are different form of variables? From, again, specifically Python perspective here. There are four main type of collections of variables in Python. And again, I want you to pay close attention to this part because this is really important. Data types, these ones are what you're going to use often in basically different experiments. So we have list, we have tuple, we have set, we have dictionary. Now we're going to check each one of them. So a list is an ordered and indexed collection of values that are changeable and allows duplicates. So again, I want you to focus and pay attention to all these keywords. So they're ordered, they're indexed, and they're changeable. You can change them. And they do allow for duplicates. So for example, if you're writing a program, or if you're writing a method or a function, and that function will accept duplicates, you know, as a rule of thumb, we should use lists because you can change them and you can add duplicates to them. So here is one simple example. Of course, they're basically, we have square bracket, and then you can see different types of data. So again, just put that in chat. What's the data type of this one? In general, what are the data types that exist in this list? Who can specify? Who can put them in the chat? String, integer, what else? We have another one. Floats. Okay, example. So we have string, we have integer, and we have float values. Again, it's really important to know the distinction between these two. String and float, they're different. So if you're using, for example, again, if you're doing scientific programming, if you use basically floats with one or two decimal points, you might get, for example, some precision error. Or if you use, for example, up to n decimal points, for example, who can tell me what are the number of decimal points here? Very simple. We have up to 6 decimal points, right? So it's really important to pay attention to these details, especially when you're doing scientific programming with Python. And it's really important to know it's different. This data type is different from 2. So we should have a distinction between these two. Oops, I'm sorry, 5 decimal points. Thanks, Ashba. 1, 2, 3, 4, 5. Thanks for the correction. That's good because I know that you're listening now. Okay, so, and of course we have print statements to basically print different values. So what other thing that I want you to pay attention is how we do indexing, how we can access different values of this list. So if you pay attention, we start from 0. And you can see the elements at the 0th index is Dan. So it doesn't start with 1. So again, that's something you have to be careful about in Python. I know, for example, some of you, if you're familiar with MATLAB, MATLAB starts from 1. 1, 2, 3, 4 is normal. But then when you switch to Python, it might be a little bit confusing. So the indexing in Python starts from 0. So the first element is at the 0th index. And then the just to make sure again you guys are listening, what's the fourth value, what element exists at the fourth index of this list? You can tell me the fourth index. Excellent. Okay, Python. So 0, 1, 2, 3, 4, and it's a string value. So again, small details that you have to pay attention to. And of course, it's really easy to change entries for a list. All you need is to access that element using that index and try to assign a new value. So again, looking into that bucket, try to basically assign a different object or put a different object in that bucket. And that's how you assign a new value to a variable or a bucket in Python. So sample list, the element at the third index now is assigned 52. So what was the value at the third index? 1, 2, 3, 0, 1, 2, 3. It was 4. So now that's replaced by 52. So when you print that again, you see then 2, 3, 52, Python, etc., etc. And what you can do, you can also add to the list. So again, one other really good function method that can get applied on a list is this append. So you had this list, you said, I want to append, I want to add a new value to my list. And it will get added to the last item of the list. So what you want to basically add here is this string value to the back. And when you do that, there we go. You have basically a new value added to that bucket. Any questions so far? Is everything clear? Okay. So I'm just like preparing you before we getting into NumPy stuff. One other interesting stuff, like basically you can do so many different tricks to work with different elements of a list. For example, it's easy to instantiate a list of a particular size with all entries the same value using this. So I want to repeat 5 10 times, and I want to have like 10 5 inside my list, because that's what I would do. If I want to have only 3 5s, then that's what I would do. So this multiplication, this asterisk with this like number, it would just like signify repeat this number 3 times inside my list. Or we can change this. I want to have 3 actually. Number 3, the value 3 in my bucket, repeated 3 times. So these are some basically hacky stuff that you can do with lists. So now accessing data in lists, we talked about it. But like again, if you want to do slicing, so now I want to have multiple, basically, I want to pull out multiple values from my bucket. So now I look at my bucket. I have, for example, the rabbit that jumped out. Still, basically, I put that in that bucket again. I had, number 2, number 3, for example, a string value. So these all exist. These objects all exist in that bucket. So now I want to, and they're ordered, and they're like we have a sequence of them. So I want to get basically a subset of those, and I want to pull them out of my bucket. How would I do that? So again, this is a sample. This is a simple list. One example. So now you can see the values are different. They're all integer values now, and I want to basically access multiple values. That's how I would do it. And again, who can tell me if this 5 is inclusive or exclusive? And what I'm doing here, exclusive. Let me actually explain what I'm doing because some of you might not know what's happening here. So what I'm trying to do, if you again look here, here I was trying to access one element of my bucket or one element of the list. So that's why I have one single number. If I want to have multiple, then I would use this column. So what I'm doing is like, I'm just like saying, okay, give me the element at this like second index all the way to the 5th, but 5th is not inclusive, it's exclusive. So again, that's another thing I have to be careful about, just like small details. So that's what you would get, right? 0, 1, 2, and then 3 and 4. So again, 5 is not included. The same concept here, basically simple list, the second all the way to the third. But again, third is not included, it's exclusive. So again, 0, 1, 2, and 3. So we can see this is not included, we only get 2, and so forth. So tuples. A tuple, again, another important concept, is an ordered collection of values that are immutable and allows duplicates. So again, if you pay attention, again, I'll share this notebook with you guys. I think I shared that with Dr. Malik and Sebastian. So basically, if you want to get a copy of it, they can share that with you as well. So if you pay attention to the keywords, it's again ordered and they are immutable. So you can't basically change the values. And it basically allows for the duplicates. So again, knowing what each data type, a collection of basically variables in Python do and the characteristics of them would help you decide better what to use in certain circumstances, certain situations, use cases. So here how you define a tuple, a simple tuple. So we have all these values inside this simple tuple, 12, 42, 11, 99, 23, 51. And again, I'll print them the same using the same way. And again, as I mentioned, it is not possible to change entries in a tuple. So if I run this, and if I run this, if I comment this out, and then run it, you would see I would get an error that tuple object does not support item assignment. So again, a specific use case of it. Let me actually ask you to make you think a little bit. What do you think would be like, in what situations would you need tuple? Like just in terms of use cases, what can you think of? If you can put them in the chat. Like when, in what situations do you think a tuple would be suitable? Again, in terms of use case. Any ideas? Anything that you can think of? Hash grid, yeah, if you don't want to allow for basically change of assignments, coordinate pairs, if they're fixed and you don't want to change them, and you know, basically they're correct and they can be replaced. Excellent feedback. And Farhad, excellent data sets that are not changing. Love all the answers. Encapsulation, encapsulation is a different basically topic. So don't confuse basically them, Yash. But very good to see basically see that you're familiar with it. But yeah, all we talk about here is a data structure that basically you cannot change the value of it. But yeah, talk about encapsulation later. Okay, so okay, that's an important property of a tuple. So, but what you can do, again, as I mentioned, you can add values or you can basically get rid of values from a tuple. So that you can do. How, for example, let's see another example of it. Here's a simple set. We have 11. Basically, we have a basically 11 minus 2, water, and basically this. So you can change values, but you can add and remove entries from a set. So here I'm basically adding 72 to this set, and I'm removing, for example, water from this set. So again, we have this tuple and we have this set. The idea behind tuple and set is you can't change the values, but you can add or remove values from it. Excellent point. Thanks. And one very important data structure that I want you, again, once even after the session is done, after the session is over, I want you to actually practice more with it. It's like dictionaries. Dictionaries are very important, and they're commonly used in so many different basically use cases. And the reason for that, a dictionary is a collection of values that are unordered by index and changeable. So you can think of them as like a collection of different values that are tagged. So here is a simple dictionary. You can see these keys and values. So we have a concept called key and value pair for dictionaries. And for brand, for example, we've assigned a specific value, Apple. We have this other key, which is product. And for that key, we have a specific value called iPhone. And we have another basically key, which is called model. And for that model, we have a specific value called X. So again, dictionary is just like a nice way of representing key value pairs, which are unique. So they're indexed and they're changeable. You can change them. And again, we can print different values of a simple dictionary using print function and indexing. So again, if you pay attention, I'm just like saying, okay, give me the value of this key. So I bought an simple dictionary. I'm using again this indexing, but I'm actually giving it this value, this key, because I want to fetch the value of this key. And then what's, but again, who can tell me what would be the value of this? If I print this, what would it show? Again, you can see it here, but just like to make sure you're listening. Any ideas? No? iPhone, right? So I'm just like saying, give me the value of this key, and the value of this key should be iPhone. Exactly. So here are some more examples before we jump into NumPy. We can also add entries to the dictionary, so you can extend your dictionary. There's like set of collection of values. Here is one example. I don't have if you look at my dictionary, I don't have any key called color. So again, who can put in the chat what are the keys inside this dictionary? Just to make sure you fully understand dictionaries, because this is an important concept. Brand, product, model. So these are the keys, and these are the values for my keys. If I want to add a new key, that's how I would do it. So again, I would assign a value to the key using equal sign. So now I'm adding a new value, a new key called color, and I'm assigning this black value to it using only one single line of code, like this one. And there you go. If I print it, I would have brand. You can see it's basically separated by colon. The brand name is Apple. Key value, key value, key value, and key value. And I have like basically this color, which is now red. I think here somehow I changed that, so it should be black. So if I run this again, simple dictionary is not defined. I have to run this cell. I'm gonna run this. And then if I print my simple dictionary, it should be black. But if I change that to red, then again, you should be careful about uppercase and lowercase values. Then there we go. It should be red. Do you guys have any questions so far? Is everything clear? Nice. Glad to hear. No one is falling asleep, right? Let me know if it gets if it's getting boring. Okay, so now introduction to NumPy and pandas. First, we start with NumPy. NumPy is very strong toolkit that you would often use in scientific programming, along with pandas, which you will get to basically next. So what is NumPy? NumPy stands for numerical Python or numeric Python. It provides fast mathematical computation on arrays and matrices. Again, we talk about what arrays and matrices are. Basically, here I have a photo that describes the differences between a list and an array. And again, it's really good to have it as your basically cheat sheet or some like a reference, so you know the differences. And it's pretty fast. NumPy provides the essential multidimensional array-oriented computing functionality designed for high-level mathematical functions and scientific computation. So here you can see some of the differences, distinctions between lists and arrays. A list contains elements of different data types, right? You could, for example, distinguish between string, integer type values, floats, etc. Array, on the other hand, contains elements of same data types. So this is really important to remember this. When you're using array, the elements of an array should be of the same data types. So that's why at the beginning of the session I mentioned you should get familiar with the data type of the data that you're using. If you're not sure what the data type is, you have to go back and check the data type again. So again, another distinction, list explicitly importing module is not required to declare a list. As you saw above, we just basically use the square bracket and we define different values and different, basically a simple list. And that was it. We didn't need to import any library. But for basically arrays, we need to import a module explicitly to declare an array. And you will see basically how it's done. List cannot handle basically arithmetic operations. You can do basically some arithmetic operations on it, but through some hacky ways, but by default, by nature, they don't handle it. Arrays can handle arithmetic operations by default. So there are so many different functions, methods that can get applied on arrays that can do so many different things, and you see them. Lists, mostly used in the shorter sequence of data elements. When the data elements are short, they're not exhaustive, they're not huge, while arrays mostly used in a longer sequence of data elements. And the reason for that is because like the nature of the arrays. They can, again, contain elements of the same data types, they're fast, and you can have different arithmetic operations on them quickly. When if basically the sequence is large. So again, lists, easy modifications like addition, deletion, and update of data elements are done. Sometimes an arrays, it's basically difficult to modify an array since addition, deletion, and update operation is performed on a single element at a time. But again, there are different functions that you can apply that basically can help with this issue, make it better. So we can print the entire list without the help of an explicit loop. And basically to print or access array elements will require an explicit loop. For easy addition of elements, large memory storage is required, but again, as I mentioned, arrays, they're optimized for large basic sequence data. So in comparison to the list, it is more compact in memory size. So again, you're picky about your memory operations, and basically the performance, the perf, and all that kind of stuff, then of course, by naturally you would go to arrays. That's why you would see a lot of lower level codes, especially algorithmics, from the algorithmic point of view, are all arrays. Okay, so how would I use arrays? There are several ways to create an array in NumPy, like NP array, NP zeros, NP ones, and again we talk about each one of them and what they are and different operations of them, just like to get your hands a little bit dirty and see how they work. So first of all, you have to import them explicitly. So import NumPy, and again this is just an alias to make the name shorter because us engineers or scientists are a little bit, scientists not, but engineers are a little bit lazy, so they want to use like a shorter names for everything. So there we go. So import NumPy as NP. And then here, that's how you would define a NumPy array. So again, this is a variable. What is the type of this variable? it's of type ND numpy array. So numpy array, and that's how you would basically assign different values to this numpy array. So we're basically assigning 1, 2, 3, and we're also declaring the data type explicitly. So that's the basic beauty of numpy arrays. You can explicitly also mention force the data type. So, and that's a good practice to do. You can bypass this, but I would suggest you to, especially if you want to do systematic programming, always include this. So for another programmer, another scientist, another collaborator who wants to take a look at this, you can just like basically take a look at the data type or use some of the functionalities on NumPy arrays to access the data type, which you would see. So always use this. It's a good practice. And you can see it's float 32. I can see a question from Sergio. If you force the data type, you cannot append the type other than the one specified. That's correct. And the other benefits of this, Sergio, is like you would see basically shortly that you can use a function that would basically return the type of values inside your function, inside the array. And another peer of yours can basically quickly go and just get the data types and make sure the data types is what has been mentioned here. So again, it's better for debugging. It's more systematic, and it's basically a good practice. So now we have a NumPy array with these values. So we have this function in Python called type. If you basically do type A and print this, you would see that it would return NumPy in the array. And then basically we have this prints. So again, I'm using the prints. So we have basically print type A.shape. I'll talk about A.shape, and A0, A1, A2. And then I'm printing this. So I'll talk about this one. Let me see. Alien has a question. What does 32 mean? So basically, that's the precision of that float. So basically, we have float 62, 32. It's based on the operating system. 64 is like more precise. So it's like it goes basically based on the precision of the floating points. So again, I'm not going to get into that, but it's like if you're very picky about the performance and just like the differences between float 32 and float 64 and so forth, I can basically send you a link like after close to the end of the session, so you can check them out. I see another question. Is there a reason variable A uses this in assignment, but variable B uses this? No, not really. Basically, you can use either square bracket or you can use this. So, but basically, this should be in form of this numpy data array. Right. So that's the key. That's a takeaway. And again, make sure to include this. NumPy dots, let's set floats 32. Does that make sense? And Rishba has mentioned 32 means 30 bit floats number. Yes, exactly. So as you can see, now I've basically created two NumPy arrays, each with different values. And the data type is float 32. And I can print them. I can do different operations, have different operations on them. So one very nice way of just like checking the shape or the dimension of your array is this shape function. So if I do, let's say, a.shape here, because now I have A and B, you would see 3, comma, by nothing. So that's what this entails. It just basically tells you that you have 3 numbers inside your NumPy array. So it's like a sequence of numbers. Does that make sense? Is everything clear up to this point? Excellent. Okay. So again, I want you to remember this. Shape is a very important and functional function that you can use to get the dimension of your basically array. So Yash, what if there was a number after the comma? Oh, we'll talk about that. Yes, we talk about the multi-dimensional arrays. We're not there yet. Yeah, you'll see that. You see how it would be. Yes. Okay, so now we have. This is another example. Again, as I told you, some people would prefer to do this without specifying the data type. It's okay, but it's always a good practice to do that, to be more explicit, especially if you, for example, the code wants to be production ready, if you're working on a system that wants to get into production, then that needs to get into production. So just like the small details. Another really nice function that you can use on top of an array is sort. So you would see here the sort function that is basically applied on this, and when it gets applied, the numbers gets basically sorted. Basically from lowest to the highest, here we have 1, 2, 4. So again, here the numbers weren't sorted, and now after this sort function, they're sorted, 1, 2, 4. So now going back to the NumPy arrays with more dimensions. So if you see here, now I have two basically square brackets. What it would signify and what it would entail is that now we have a rank 2 array, like a two-dimensional array. Before getting into that, just like again, to make sure you guys are listening, who can tell me what is the rank 2? Does anyone know actually what a rank 1 or and rank 2 array, rank 1 array and rank 2 array is, basically? What is a rank 2 array? Does anyone know? Any idea? Any guesses? Samuel says 3, 2. I don't quite understand that. Rank 1 array is a 1D array. Samuel, wait, so it column? Yes, Samuel. So Rishma, great answer. Sergio, rank 2 would just have 2 dimensions. Yes, great answers coming in. Happy with the answers. So basically, as guys mentioned, no worries. Yeah, that's all good, Samuel. Yeah, I understand. But good answers. Very, very good answers. So when we're talking about rank 1, in terms of, again, you're right, Samuel. In terms of, we're talking about the basic NumPy arrays in Python. We have basically a one-dimensional array, just like a sequence of numbers, like a line. When we talk about rank 2 arrays, now we talk about matrices, right? Column and rows. So rank 2 arrays, 2-dimension, column and rows, X and Y, right? And then we have higher ranks. For example, rank 3 array, which we might not get into this session, but it's good for you to understand what they are, what they would entail. So it's like a 3-dimensional array, X, Y, Z, and so forth. High-dimensional arrays, which you might also use, for example, later for image processing and stuff like that. That sometimes it's really hard to visualize in your mind, in your brain, but there exist higher dimensional arrays. So when we talk about rank, we talk about basically this dimensionality. So here at the top, rank 1, it was just a sequence of numbers, right? So just like the line. But here we have a rank 2 array, X and Y, a matrix. So when we print that, you would see it here. We have, for example, X and Y, rows and columns. So 1, 2, 3, 4, 5, 6. So this is a rank 2 array, it's a 2-dimensional array. And the way you can do it, of course, there are functions that can change the dimension, which we will get into. And also you're using the shape function. We'll check this one too. But you can also look this a square bracket. We have 2 square brackets, entailing that the rank is 2. So if I v.shape, let me make sure I ran this. You would see now we have column and rows. Like here we have 3, comma, there was no number, meaning that it's a sequential, it's like a 1D rank 1 basic NumPy array. But here we have a matrix, a 2-dimensional array. So we have 2 rows, 3 columns. So that's what it entails. The first one is the number of rows. The second one is the number of columns. 2 rows, 3 columns. Does that make sense? Is that clear to everyone? Okay, nice. Okay, let me also make sure we are on the track with the time. Yep. Okay, so now we're getting into so as I mentioned, NumPy arrays are nice because there's so many different functions, like this shape function or method that you can use to do different things for your purpose. For example, shape would return the number of rows and columns. Sort would basically sort the number of basically the elements inside your array that you had. We'll get into some of these ones. Item size, we basically get the size of the items inside, for example, in terms of bit size. So this is basically the number of bits that elements of an array would occupy. Again, if you, this is just like you wouldn't use it much, but this is just to get you familiar with some of these stuff. So you have basically you would have exposure to some of these functions. So NumPy ones, something that again is very useful sometimes when you're doing experimentation is this. It would create a matrix, or again, array of, maybe it could be a sequential array of only number 1 inside of it. So here how you can use it. So here I would specify np.ones. I would specify the number of columns, the number of rows, and the number of columns that I want. So 3 rows, 4 columns, and of course I would specify the data type. And again, all the data types should be the same. That's the rule of thumb for the NumPy arrays. And here in this case is integer 16. So you can see we had float 32 previously, now we have int 16. So again, this is just like in terms of bit size and all that kind of stuff, memory operations, if you're actually a little bit curious about the performance and all that kind of stuff, you might be picky about this. Precision. Again, I'll send you a link so you can learn more about this stuff. Difference between integer 16, 32, 64, and all that kind of stuff. But that's how you can basically initiate like just an array of ones. Here how you can basically print this. You would see we have 3 rows, 4 columns. Another very nice function is NumPy arrange. So basically give you a range of numbers with a step. So this is a step. Basically between 10 and 30, I want to basically produce 5 numbers equal basically as a step based on the step, like 5, 5, 5. So when you print this, you would see we have 10. You have this step based on the step 5, you have 15, 20, and 25. So this is the start, this is the end of the range that I want to have, and the step number. This is the step number. And you can have it with the lower range too. So like NumPy a range, so 0, between 0 and 2, and I want to have this step, very tiny steps. So again, one function of this, the way you can use it is when you want to do plotting. You want to use a plot. You want to, for example, plot something. Or you have a function that, for example, needs to generate this interval for a purpose, for another function to consume. So again, that's the benefit of using NumPy arrays. A linear space, this is also nice. It gives you an evenly, so again, here you can also see what it does if you using Google Colab, and if you're using, for example, NumPy, if you go and hover your mouse over each method, it would tell you what it does. So again, that's a nice way of learning as well. So again, if you go here, you can see it returns even a space number over a specified interval. So what is my interval? I want to basically between 0 and 10. Here I've specified 6 numbers. There we go. It would basically generate this based on like the evenly spaced interval. So 0, 2, 4, 6, 8, and 10. And of course, NumPy random, pretty common and straightforward, just like generates random numbers. I would specify that I want like 2 rows and 3 columns, and I would get this matrix or array of this shape, rank 2 of these random float values. So now I'm going to talk about some of these ones, and then how you can do more advanced slicing or indexing of different NumPy arrays. Some of the important attributes of NumPy objects are, again, we have this. We check them in practice and you see how it works. And dim, which basically displays the dimension of the array. We have shape. You got familiar with this. Returns a tuple of integers indicating the size of the array, the number of rows and the number of columns. We had the size, which would return the total number of elements in the NumPy array. We have the D type, data type, which basically returns the type of elements in an array. For example, integer 64 character. And we have the item size, which returns the size in bytes of each item. And of course, reshape. This is very important. Actually, we'll see how we can use this. But it reshapes the NumPy array. Basically, if you have like a 2 by 3, 2 columns, 3 rows, you can reshape it. You can, for example, reshape it to have 3 rows and 2 columns. Like you can change the dimension. So if we want to get some idea how this would work, for example, we had this B. If I print B here, we had this array. If I print this, I would have this array. So now I can apply all these functions on it. So dimensional, it would say like I have 2 dimensions. Then I can also do shape. It would give me the number of rows and columns. I can say data type. It would just say integer 64, and so forth. I can say size. Oops. Being careful about the uppercase and lowercase. There we go. I get like 6, for example, the size, the number of elements. Okay, before getting into the slicing, I'm choosing multiple elements of a NumPy array, the same way that you saw in list. Using list, you guys have any question? Is everything clear? Okay, excellent. Just to give you, again, a recap, we talked about lists. We talked about how lists are instantiated, and we talked about how we can access different elements of a list. Do you remember? We said we can basically choose a specific elements. For example, one single element using just specifying the index number. If we wanted to use multiple values of a list, then we would have, for example, these 2 numbers specifying the index, the first index of the element that we want to choose, and the last one was exclusive, and then we would be basically using colon. So keep that in mind. For NumPy array is going to be the same, a little bit fancier, but the same concept. So for array indexing, just to start, NumPy array elements can be accessed using indexing. Below are some of the useful examples. So again, you remember lists. with numpy arrays, if you have this A, which is a matrix, or for example, this P, imagine this P, if I would specify 2 to 5, the same way as list, we'll print items 2 to 4, and again, index in numpy arrays starts from 0, so the same concept. A2 double colon will print items 2 to end, skipping 2 items. So again, you don't need to memorize this stuff. I mean, this stuff would come naturally to you. So as you practice more, as you do more case studies, you would learn how to use them, and basically it goes into your system. But you don't need to memorize it now. You can use this cheat sheet as you use it, it goes into your system. So don't worry if, for example, some of these look odd. And then this one, double colon -1, will print the array in the reverse order. If you ever see this -1 indexing, know that we're indexing from the end of the array or the end of the list. So this basically is a hacky way that we print different elements of an array in a reverse order. And again, 1 colon, you basically see there's no number after this, will print from row 1 to the end. So there's no limit. That's why we don't put any number after the column. Now you would see some examples here. Of course, I put like a reference here so you can actually use more, you can check this out and do more basically practices so it can get into your system. Similar to Python lists, numpy arrays can be sliced. Since arrays may be multidimensional, so you must specify a slice for each dimension for the array. Here you can see we create a rank 2 array with shape 3 by 4. So again, just to make sure you guys are listening, what do these two numbers entail? What do they tell me? 3 and 4. Excellent, nice. Row and columns, nice. So 3, number of rows, 4, number of columns. So here I want to basically create such numpy array. That's how I would do it. You see that I'm not importing numpy as np anymore. Why? Because I've done it one time here at the top and I've executed the cell. So that's good now. I don't need to do it again. Okay, if I hadn't imported the numpy library, I would have to do it again here. So I would have to come here and then do this. Import numpy add np, and then there we go. So here I'm creating another numpy array with all these elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, it's a better practice to specify the data type. Don't be like me. I was just like lazy trying to put stuff together, but try to specify the data type. It's a good practice. And then here, you basically try to slice and fetch a specific elements of that matrix to the numpy array. So see how I would do it. Once you get one example, then everything else would fall into place. Like, it's very straightforward. The way I do it, you would see I have 2 values separated by comma. So the first one is number of rows, right? The second one was the number of columns. So what I'm trying to do here, I'm trying to access and filter based on a specific number of rows and a specific number of columns. So here, I'm trying to get the first 2 rows. That's why you don't see anything before this column, meaning that starting from whatever row that is, all the way to the second one, and stop there. So just give me the first 2 rows, and then column 1 and column 2. So this is exclusive. Column 1 and column 2. So give me the first 2 rows and only column 1 and column 2. So when you look at this, what would I get? I can get this, right? Give me the first two rows, but column 1 and column 2. And since the indexing starts from 0, this is 0, 1, 2. There we go. 2, 3, 6, 7. That's what I would get here. Does that make sense to everyone? Is this clear? Okay. So a slice of an array, again, is a view into the same data. So modifying it will modify the original array. So you got to be careful. If you modify a specific value, basically it gets replaced. Arrays, you can again modify different values. So here, who can tell me what I'm trying to do? What does this entail? What is this? 0. What does 0 entail? And what does 1 entail? You can put in the chat. 0 and 1, what do they entail? Row and column. So 0 is 0th row and first column. Excellent. Sergio and Rishab. I'm sorry if I'm pronouncing your name wrong. The value at that row and column. Yes. So if you print that, you will see you get one single value. Why? Because I'm trying to access that single value from that row and column. So the 0th index, 0th row, first column. So 0th row, first column. This is 0th column. So again, Python indexing starts from 0. Be careful. And then I want to replace that value by 77. So that's how I would do it. I would just like, okay, give me B. Actually, this should be A. I think I just changed that. Because I had created this NumPy array called A. Oops, no, I'm sorry. This was B. That's right. Why this was B? Because I got a subset of that, and now I want to replace it. Right? This was B. And here, I'm just like replacing this, not the original one. So I replaced that value by 77, and basically I print the value. Now it's replaced by the value is now 77. So the takeaway here is this is slicing and how you can actually replace different values from like a specific row and column of a NumPy array. Does that make sense? Okay, now we're getting into the mathematics of different arrays. So as I told you, there's so many different good functions that you can use on top of the array to do mathematical functions. Makes like your life much easier. With lists, naturally, you wouldn't be able to basically do much. You could do some hacky stuff to actually get into summation and just like deletion and all that kind of stuff, multiplication. But naturally, NumPy arrays would allow you to do such arithmetic operations. So here, for example, I've defined two different arrays, x and y. You would see the data type again, 1, 2, 3, 4. What is the rank of this array? Who can tell me? And how many rows and columns do I have in there? So question number 1, what is the rank? Question number 2, how many rows and columns do I have for x and y? Rank 2, excellent. Rank 2, how many columns and rows? 2 rows, 2 columns. Okay, excellent. So that's good. You guys are all listening. So now we print basically this x plus y. The beauty of NumPy arrays, it just like naturally does the element-wise sum for you. So you don't need to do anything else. That's it. So you have 1, 2, 3, 4, 5, 6, 7, 8. So basically, if I print x, so you would see it better before their sum. So let me create a cell here. Here we've got x. You got x in here. 1, 2, 3. Oh, actually, this is not the x. Let me run this again. Run this again. So we have 1, 2, 3, 4. And we had y, 5, 6, 7, 8. Let me basically do the same for y. So when you do this, we sum different elements, each elements together, right? So 1 plus 5, 6, 6 plus 2, 8, 7 plus 3, and so forth. And that's all you need to do, and that's it. There are actually two ways to do that, x plus y, or you can do numpy.add and give it these two numpy arrays. Just add these two numpy arrays together. Or you can directly say, give me x plus y. The same thing for multiplication and all the other stuff. So let's look at the subtraction. If you want to do like element-wise differences, that's the same thing. X minus y, or numpy subtract x and y. So again, the same thing. If you look at this element-wise subtraction, and look at the order, it's ordered. So that's why 1 minus 5 minus 4. 2 minus 6 minus 4, and so forth. And basically you can accomplish the same thing using numpy that subtracts x and y. So you can see minus 4, minus 4, minus 4, and minus 4. You can see the same matrix here. So these two are the same, accomplished using two different methods on numpy arrays. Another nice thing, element-wise product. So we can basically say x multiplied by y, and it does the element-wise multiplication. So now here, one thing that I want you to pay attention to. I know some of you might come from like MATLAB programming and some other programming languages. This asterisk is an element-wise multiplication. It's not a dot product, okay? So, because I know in MATLAB, when you do that, it does the actual matrix multiplication. So here is an element-wise multiplication. And again, there are two ways to do that. Multiply, or basically x asterisk y. So again, 1 multiplied by 5, 2 multiplied by 6, and so forth. Samuel has, would it just return a 2 by 2 matrix? Which one, Samuel? This guy? Would it not just return a 2 and like why adding x plus y when this does return a 2 by 2. So if you see these two, this is the result of these two print statements. Is that what you're asking? Oh, I see. Okay, I'm a little bit confused about Samuel's question. Sebastian, can you? I mean, like when adding x plus y, why is it not return? No, it does return a 2 by 2 array. I think it's because here I'm printing two different things. So like let's go x plus y. So these two, I'm printing these two. That's why it's basically printing these two yeah. It's my bad. I have to basically put like prints like separate line on it. So it could have been basically better. Basically, yeah. This is the result of the first one. Like I want to show you that these two are the same using two different functions. So yeah, it returns like a 2 by 2 matrix. And you can accomplish the same thing using add function, add method. So that's why these two are the same. The same for this one. Let me actually copy and paste. Yeah, it's better to do this because it's a little bit confusing for you guys. So yeah, again, it does return a 2 by 2, but you can accomplish the same thing by using two different methods: subtract and like this minus y. The same thing here. Multiply x and y, and the same thing here, division. So again, I paste this here. So again, multiple element-wise division. You can either do this or you can do this. It doesn't matter. This is like simpler, right? Less number of characters, if you will. And then some other stuff, some other mathematical stuff. For example, SQRT, like the basically a square root of the elements. So you can do the same thing. NumPy.sqrt, it's the same in MATLAB, I know, and some other languages. And X, and it does the element-wise square roots and produces the array 2 by 2, and there we go. I've actually put the notes here, so be careful about it, because unlike MATLAB, asterisk is an element-wise multiplication, not matrix multiplication. So that's, if we're coming from that background, we got to be careful about this. We talk about the dot product here. So if you want to do a dot product, there's like a specific method for it. So again, I would have these two matrices, X and Y. They're 2 by 2. Again, if I want to, just a pop question, if I want to check the dimension of this, what was the function for that? So let me actually execute the cell. Let's say I have X. I want to get the number of rows and columns. What was the function for it? To n dimension or shape? Shape, you can just like, I can use the X dot shape, and there we go. It gives me 2 by 2. And you would often use this, especially when you want to do debugging in like bigger systems, or you get into deep learning stuff and you want to make sure everything is, you don't need to worry about those stuff yet, but just I want to signify how important, for example, some of these functions are. So it's good to get familiar with those. X.shape. You use X dot n dimension, it will give you only one number, a 2-dimensional rank 2 matrix. Excellent, good. So I would have these two matrices, X and Y, and then I would have the dot product. I want to get the dot product of these two. So what I would do, let's say here, actually I have V. This is, I think these two are extra one. I put it for a different purpose, but I didn't get rid of it. V and W, again, these are, again, what would, someone actually tell me what's the rank of this one? What is the rank of this? It's 1, right? So I can see V that's W or NumPy that's V and W, and I can get the dot product of vectors. Both produce basically 219. Again, these are two different ways of doing this. So again, I will put this just to let you know, these are two different methods, but they produce the same result. So dot V, dot product W, or you can say NumPy dot, and then pass it the two arrays that you want to have the inner product of vector dot product. One fancy or like hacky way, it's not basically recommended, but if you want to, like if you're pretty lazy and you want to do something fancy or hacky, you can use this, and it does the same thing. It's like you can also use the at operator, which is equivalent to NumPy's dot operations, the dot's product. So this also produces the same result. Why would I say it's not recommended? Because it's really confusing. You can get confused by a lot of other characters, especially when it gets into like a system that is huge with a lot of components, production level system. You might see it in academia, in so many, for example, repositories and stuff like that, but in industry, it's not recommended, so don't use this. So NumPy provides many useful functions for performing computations and arrays. One of the most useful one is the sum. Okay, we're right on the track with time. Okay, we have broadcasting, and then for the next session, I'll talk about pandas and matplotlib and the use case study. So where were we? We're here. NumPy provides many useful functions for performing computation arrays. So again, sum is another one. I have these two arrays. I have this one array, NumPy array, with these basically values. Again, this is a rank 2 array. And then basically the sum, NumPy.sum x, would basically compute the sum of all elements. And then it prints basically 10. So 4 plus 3 plus 2 plus 1. So now you can get a little bit fancier with it, and you can specify the axis, because you can see 1, 2, 3, 4. If I print this, let me print this. So Alien, it's a dot product. I can see. I see a question. How did you calculate to 119? It's a dot product. If you know how the dot product is like a multiplication plus the, basically here it's like a two sequence. So you just like multiply them together. But like if you have an n by n matrix, basically calculates the dot products, the inner product of a matrix. If you search for that, I can send you the link. That how basically that is done. So basically for this one, again, if you look at this x, let me type it for you. You would have this. So when you do sum, this sum on its own, basically it sums all the elements of that matrix. But again, as I told you, you can get a little bit fancier and you can specify these arguments, like axis along the zero, basically axis 0, which would only sum each element of basically sum the numbers of each column. So now you would see, for example, we have 1 plus 3, 4, 4 plus 2, 6. So it computes sum of each column by specifying axis 0. So now when you specify axis 1, it basically sum elements across the rows. And that's how you would get this 1 plus 2, 3, 3 plus 4, 7. Again, I've put a link here for full list of mathematical functions. There's so many that actually you can learn to do on NumPy arrays, mathematical operations. So one other important thing that I put here is the transpose of a matrix. Again, apart from computing mathematical functions using arrays, we frequently use to reshape or otherwise manipulate data in arrays. One way is to, for example, transpose a matrix, right? Switching rows and columns, if you know from algebra. So again, NumPy arrays can help us do that very easily using this T, uppercase T. So we had this NumPy array of rank 2, shape 2 by 2. And here it is. I only need to say x dot uppercase T to transpose it. And there we go. I have basically a transpose matrix 1, 3, 2, 4 of the original one. So this is transpose, and now we have this. And now we get into the last basic section, important section of today's session, which is broadcasting. One very important basically characteristic of NumPy arrays is that they would allow you to do broadcasting. So now, what is broadcasting? Broadcasting is a powerful mechanism that allows NumPy to work with arrays of different shapes when performing arithmetic operations. Again, I'll show you examples so it can fit into the picture. For example, suppose that we want to add a constant vector to each row of a matrix. So we have a matrix, we have to just like add a constant vector to each row of it. Someone might go and just like conventionally do something like this. So now let's see what's going on. Originally, we have this array of, again, who can tell me what's the rank and what's the number of, two questions. What is the rank of this array? What are the number of rows and columns for this array? X. I can see someone is saying rank 4 rows, 3 columns. Okay, let's give it a 5, see what it is. So again, you can use X, right? Dot shape. And then you can use n dimension. So it's a 2-dimensional array. It's a matrix. We still have a matrix. It's a 2-dimensional array. So that's, don't fall into that basically loop, that hole. It's a 2-dimensional array. See the number of basically opening square brackets, but we have 4 number of rows and 3 number of columns. 4 number of rows. Here you can print this, and 3 number of columns. Oh yeah, sounds good, Sebastian. Thank you. Thanks for the reminder. So it's a 2-dimensional array. This v dot shape is for this array. So I'm talking about X. So X is a 2-dimensional array that has, again, it's a matrix, X and Y. But what we have 3 number of rows, 4 number of rows, and 3 number of columns. So again, broadcasting, someone might go and do something like this. I have this V, I have these 2 matrices. Basically, I have X and I have Y. And I want to basically, what did I want to do? Actually, I lost the, I want to add basically this content, multiply this by each element of this basically X. Someone might go and do something like this. You might say for I in range 4, for each one of these rows actually inside this vector, one by one, go and just like multiply this one and produce the results. So someone might just like use a for loop to do that. The problem with this, it can be done, but it's basically exhaustive. And there's an easier way. The whole point of using NumPy arrays is to allow you not to use for loops. So you don't need to do that to basically multiply the constant v to each element of, like, for example, x. What you can do something like this. Y equals x plus vv. Let's see what's happening actually here. We have v. We basically create vv. Again, here you get familiar with another function called tile. It basically stacks n copies of the same matrix on top of each other. So we have, for example, we're stacking 4 copies of v on top of each other. So we would end up with this. And then we can add basically x and vv elements, because now we would have the 2 matrix with the same shape and we add them together. That's one way of doing that. Or simply we can do this. We can say y equals x plus y, and that's all you need to do. So that's the power of broadcasting. You don't need to use for loops, or you don't need to come up with any fancy way to multiply only one constant, like a vector, to elements of another matrix. All you can do, you can just, like, for example, say x plus v, like add v to each row. I say the multiply sum, actually. We can do the actually multiplication too. Add v to each row of x using broadcasting. So that's the power of broadcasting, and that's the concept of broadcasting, that basically NumPy arrays do it for you automatically. You don't need to basically reshape the array or do a for loop to go through each one of these and then basically add each element of this to each individual elements of x. When you do that, NumPy arrays would automatically sum this to individual components of basically each row. And that's it for today's session. I think we have 10 minutes, I think Sebastian mentioned, for Q&A. And then for the next session, we'll cover pandas and some other stuff.
Thank you so much, Sam. So now is a good time to ask question if there is something you did not understand. Amina, when is the next session? So that's a good question. Next session is next Wednesday. That's not going to be Sam. That's going to be a session on OOP, and you're going to meet Sam again next Sunday. So, and with these 3 sessions, this one, the second one of Sam, and the OOP one, you're going to finish the intro to Python with all the scientific background that you need to start with AI concepts and machine learning. Where can we find these notes? Also, the Google Drive I reviewed in my email is not working. Okay, so good to know that the email that you receive is not pointed to the right link. I have sent the link today in the chat. I'm gonna send it back. Give me 2 seconds to find it. We're gonna make sure to put the right links next time. But actually, it's supposed to be in slide 1, so I'm gonna share the whole folder with you guys and put it in the link right now. So the next session is Sunday. No, the next session is next Wednesday. Sorry for the confusion. It's just that we're gonna see Sam again next Sunday, but next session is Wednesday, and then the second part of the scientific programming will be next Sunday. Oh, sorry, I sent a direct message and not to everyone. Let me send it again. So yeah, so if there is any question about today's session, feel free to ask it now. If not, you can still play around with the notebook because you have it, and you can also ask questions to Sam at the next session if you have had time to review and you don't understand a concept. So next session is 10th and then the 14th. Yes, actually, we're going to be sending a Google Calendar soon so that you can check for all the coming workshops. It's going to be simpler. But yes, usually we're always going to have session on Wednesday and Sunday. Do any of you guys have experience with Julia? I'm trying to learn that for lab in the summer. Is there a lot of overlap with Python, like how the library works, etc.? So Samuel, that's an interesting question. It's a good question for the Discord chat. Right now, it's not necessarily the time to ask it, but if you just want to copy paste your question and put it on the Discord chat, that's a good thing to ask there. I would like to thank Sam very much for his time and his experience. I really appreciated the workshop because I've seen it was very interactive. A lot of you guys took part in actually answering the questions, and that's what we like to see. That's why we give this workshop, so that you can progress at a high speed, because this is not like a semester-long course. This is really workshops that are condensed in technical content, and I'm really happy to see that there is interaction between all of you. So thank you very much. I would like, to thank our instructor very much for his time. And if you don't have any more question, I guess we will see you guys next Wednesday. And thank you very much, Sam, for your time and expertise.
Absolutely. Thanks, Sebastian and Dr. Maliki for.
Thank you, Sam.
Thank you.